Next we'll look at stretching. And first we'll look at stretching vertically. When we stretch vertically, what we do is we multiply every output by a factor, and we'll label that factor A. So essentially what we do is we take the outputs and we multiply them by A. So let's say we want to stretch vertically by a factor of 3. Then we would take f of x as is, the x plus 3, x minus 1, x minus 4, and multiply the whole thing by a positive 3. That should stretch our graph vertically by a factor of 3. And what we should see is the red graph that you now see on your screen. So notice the black has been stretched vertically. Well, we can also shrink vertically. So let's say instead of stretching our black graph, we wanted to shrink it. We wanted to squish it a bit. Let's shrink by a factor of 3. Well, then we need to multiply everything by 1/3 because we want each output to only be 1/3 of the original. And graphically, we get the orange graph because all the outputs have been shrunk by a factor of 3, so they're 1/3 of their original. We do notice though that we have the same roots, and that's important. Okay. If we don't want to stretch or shrink vertically, we can do it horizontally. The thing is, it's a little trickier horizontally. So let's say we had the equation y equals 2x. Well, we know that if we wanted to stretch vertically, that we have to multiply all our y's by a certain value. Now, it doesn't quite work the same way with x, because first we would have to solve for x, and then if we wanted to stretch by, say, a factor of 3, we would multiply everything x equals by 3. But since most of our equations are in terms of y, we see that to stretch by a factor of 3, we actually have to multiply by its reciprocal of 1/3. And that's the general rule, that when we stretch horizontally by a factor of a, we multiply by the reciprocal of 1/a. We multiply every input by that value. So let's do the example of stretching horizontally by a factor of 3. Then g of x equals f of 1/3 x. G of x equals 1/3 x plus 3 times 1/3 x minus 1 times 1/3 x minus 4. Graphically, we get the teal graph that you see. So that has effectively stretched our graph horizontally by a factor of 3. Notice we still have the same outputs for max and min points. They've just been stretched out. Just like with vertically, when we can shrink, we can also shrink horizontally. Let's say we wanted to shrink by a factor of 3. Then we just multiply by the 3. So we get 3x plus 3 times 3x minus 1 times 3x minus 4. That shrinks our graph by a factor of 3. So we've now squished our graph inwards as if we were pressing from both sides, and we have 1/3 of what we originally had. That is stretching and shrinking horizontally and vertically. And the main thing to remember is that when we are working horizontally, you do want to use the reciprocal.